Students, I hope everything's going well for you. By the time you watch this, you've already gone through the July 4th holiday, and I hope that you enjoyed yourself. And what we're going to do today is this is the first lecture for June the 6th, Monday. I'm going to upload a whole bunch of other ones for you as well. Please don't forget that the next test is on June the 13th. Okay, so last time we left off talking about um, geologic time. We got up to the end of the Mesozoic era, the end of the age of the dinosaurs. And this occurred 65 million years ago. What caused the dinosaurs to become extinct? Don't get confused with the other extinction 245 million years ago, which was a lot bigger, the Permian extinction, when Pangea came together. This is the next big extinction that occurred 65 million years ago and marked the end of the age of the dinosaurs. In order to understand what almost all scientists believe is the cause for the extinction of the dinosaurs, we need to go over the KT extinction theory. And so first of all, what does KT mean? Well, capital K in geology stands for the Cretaceous, the last period of the Mesozoic, and T stands for the Tertiary, the first period of the Cenozoic Era. So the KT boundary, let's take a look at the KT boundary for a moment here. Okay, this shows you the KT boundary at one location. And right here, see the sandstone that's lighter in color? And you see these darker rocks? Well, these darker rocks would contain dinosaurs and mark the very end of the Mesozoic. And this boundary between this lighter sandstone and these darker rocks is the KT boundary. In the rocks above the KT boundary, there are no dinosaurs. That means you're in the Cenozoic era. And the darker rocks beneath the KT boundary are chock full of dinosaurs. So if we want to figure out what caused the dinosaurs to become extinct, we need to look at that exact moment when it occurred 65 million years ago. An American scientist by the name of Walter Alvarez figured it out. And he took samples of the right on the KT boundary from a place in Gubbio, Italy. And he found concentrations of a very rare element, one you may never have heard of probably, called iridium. Iridium, which is IR on the periodic table. This element is extremely rare on planet Earth. But he found concentrations of iridium hundreds of times higher than what is normal. It can't be a coincidence if you take a sample right there at the KT boundary. What is going on? What's causing these high iridium concentrations? Well, turns out the only places on planet Earth where you have such high concentrations of iridium in the past is when you had an extraterrestrial impact. That means an asteroid or a comet struck the Earth, or an atomic bomb was used, like at Hiroshima, or in the atomic tests that were done in the United States and across the world by different countries. Well, we know no one was setting off atomic bombs 65 million years ago, so he came to the logical conclusion there must have been a large asteroid or comet strike the Earth 65 million years ago. And more evidence started to pour in showing that, in fact, this impact wiped out the dinosaurs. Dinosaur censuses were done. In other words, we looked at the number of dinosaurs going right up to the boundary. The dinosaurs were doing just fine, and they died all of a sudden. That correlates with a catastrophic event like an extraterrestrial impact wiping out the dinosaurs, not disease. Because if disease or competition or something else wiped out the dinosaurs, it would have been a slow event. You would see gradual dying off of the dinosaurs. The dinosaurs are doing just fine, and then they all of a sudden disappeared. We also see sea creatures called ammonites, and I showed you those earlier, but let me show them to you again to refresh your memory. These are related to octopus and squid. They were doing just fine, and they all of a sudden disappeared 65 million years ago too. They didn't gradually die off. So the fact that the ammonites died off at the same time also tells us that there was a meteorite impact. The actual crater has actually been found off of Chicxulub, Mexico. That's in the Yucatan Peninsula. Plus, we find other evidence that tells us that there was an asteroid impact. Shocked quartz. Remember we talked about that when we were talking about metamorphic rocks? Shocked quartz is found all around the crater, which, by the way, is huge. It's 130 miles long. And also other things that are associated with extraterrestrial impacts have also been found at the KT boundary, such as tektites. Tektitess. Tektites are these little globules of glass that move out away from the crater in a circular pattern. These little globules of glass are caused by the impact, and they're hollow, and they're only formed by big impacts. All of this evidence indicates that an asteroid or a comet struck the Earth 65 million years ago, wiping out the dinosaurs. Now, I can go more into it, but I decided instead I want you to watch this movie. Type this in today, the day the Mesozoic died, the asteroid that killed the dinosaurs, HHMI Bio Interactive Video. Watch this video. I'm not going to put this on my YouTube here because it takes 2 hours to upload, and it's easier just to tell you, please watch this video, and then you will understand this impact theory a lot better. But I went into it in some detail there. But watch that video. You'll see that the evidence is overwhelming that 65 million years ago, the dinosaurs were wiped out by an extraterrestrial impact. What happened next was we begin our next era of time, the Cenozoic Era. Cenozoic Era goes from 65 million years ago to now. And the Cenozoic Era is called, by most people, the age of the mammals. So after the dinosaurs were wiped out, the mammals evolved to fill all the ecological niches in the world. In other words, the big predators were gone, right? Tyrannosaurus was gone. Allosaurus was gone. The big herbivores were gone, such as the sauropods and duck-billed dinosaurs, pachycephalosaurs, triceratops. They're all gone. Well, that meant that opportunity knocked for the mammals to evolve to fill those ecological niches, so that the mammals evolved to form all of our big predators and our big herbivores and our scavengers and our small herbivores, things like rabbits and chipmunks. So the mammals evolved to dominate planet Earth, but at the beginning, who was going to conquer the Earth in terms of being the dominant vertebrates? It wasn't clear. Why? Because, for example, for the large predator spot left behind by the demise of the plant-eating dinosaurs, we had the meat-eating dinosaurs. So who would evolve to be the big predators? At the beginning, it wasn't the mammals. It was birds. Now, birds, please don't forget this. Birds are the last mammals to evolve. Birds. I'm sorry. Birds are the last vertebrates to evolve. Who came first? The fish. Then who? Then the amphibians. Then who? Reptiles. Then what? Dinosaurs. And then mammals. And the last are the birds. The birds evolved from the dinosaurs. So some people say dinosaurs are not really extinct because their ancestors, the birds, are here. So the birds first took over the big predator spot at the beginning of the Cenozoic Era. Just to give you an example, look at how big this bird is compared to this deer. Look at this horse. So we're talking about enormous birds. And there's no doubt that, I know it's hard to believe, but let me show you something. When I was a kid, my parents took me to the Smithsonian Institute in Washington, D.C., and I saw the skeleton of one of these giant birds. I was just so amazed. Razor sharp beaks, perfect for, that's the horse in its mouth, perfect for cutting into the flesh of its prey. Muscular rear limbs, could run 30, 40 miles an hour. We find thousands and thousands of these skeletons, so they existed. At first, it looked as if the birds would dominate the planet, but the mammals eventually evolved to win out. Now, who took out these giant birds? Later on, we'll talk about them, but they are the saber-toothed cats. Our ancestors had to deal with these saber-toothed cats, but these saber-toothed cats were very common in Tennessee, very muscular with long canines. They ended up taking out those giant birds. But at first, it looked like the birds would dominate. The mammals are creatures that, first of all, humans are obviously mammals. Let's make a list here of characteristics of mammals. Mammals are warm-blooded. You're right. What else? We've got body hair. The body hair for humans is just ornamental, but in the past it served the function of keeping us warm. And for animals, for most mammals, it keeps us warm. But what else makes us different than the others in the animal kingdom? Well, we have a 4-chambered heart. We have 4 chambers in our heart, opposed to a reptilian 3-chambered heart. That gives us an advantage in the battle for survival. It means we can pump more blood. And if you can pump more blood, you can have a larger brain. If you have a larger brain, it might be an advantage in the battle for survival. What else? The mothering instinct. We talked about that before. Female mammals have milk glands. And what's the advantage of that? Reptiles don't have mammary glands. What's the advantage of mother's milk? Well, it allows for the baby to grow stronger and healthier with resistance to disease. So that, don't you think that's going to be an advantage in the battle for survival? All of those things led to the mammals dominating our planet. Now, if you want to learn more about mammals and uh, we're going to talk more. Well, we'll talk more about this, but we're going to talk about it a lot more later on if you take historical geology. If you take historical geology, but for now, I'll just tell you that um, talk about the main kinds of mammals. We have monotremes. We have marsupials, and we have placentals. Those are the three types of mammals that still survive today. So let's take a look at them one at a time. Three kinds of mammals survive today. I just don't forget monotremes, marsupials, and placentals. Well, let's take a look at that, what they some of their features. First is a monotreme. Monotremes are the most primitive of all mammals. In fact, they still lay eggs. And there's only two types that are still alive. We have the duck-billed platypus. Looks like this. And we have the spiny anteater. This is what a spiny anteater looks like. Sharp quills on its back. I bet mating must be painful. Now let's take a look at it. So those are the egg-laying mammals. They're the most primitive. The second type that we're going to look at is the marsupials. What type of marsupials are there? Well, here's some different ones. The koala bear, the kangaroo, the wombat, the Tasmanian devil. What do they all have in common? Well, the babies grow up in a pouch, and inside of that pouch are these little milk teats of the mother, and the mother is going to carry around its baby in a pouch. However, almost who won the battle for dominance on the planet between these three types? It wasn't the monotremes. There's only two of them left. It wasn't the marsupials. They're only dominant in Australia. In fact, everywhere the placentals won the battle. And what advantage do placental mammals have over marsupials? Well, you know what a placenta is? If you have given birth, if you're a mother, you may have seen the doctor take away the placenta. This comes out when you give birth. Nowadays, they let fathers into the operating room. I remember when my son was born, at that time, fathers weren't allowed into the operating room. But when my daughter was born, they gave me the option of going into the operating room. They allowed fathers in. And the doctor gave, I was so stupid. Doctor said, took this thing out, and I said, I thought to my eyes, oh my God, my baby's deformed. That's just a placenta. Anyway, instead, my beautiful daughter came up next. But what is a placenta? Placenta is a food source that's held in the mother's uterus and allows for the baby to grow inside of the uterus. This gives this is a huge advantage. That's why placentals won out. Marsupials have to carry their babies around in a pouch, leaving them vulnerable to attack. If you think about it, um, when the English colonists went to Australia, there were no placental mammals. As soon as they brought in dogs and pigs and cows, they started to take over Australia. The marsupials could not compete. Placentals have this huge advantage. Since they have this food source within them, the baby grows in the womb and grows in a more developed state. It can grow faster and stronger and healthier. Whereas in a marsupial, they're carried around, all these little babies are carried on this pouch. So they're very immature. The mother gets attacked, the babies uh, easily get killed, and the mother gets killed. So anyway, the placentals won the battle for dominance. We are placental mammals because when you grew up in your mother's womb, you fed on the placenta. Now, what is a hominid? Hominids are humans. Only one type of human exists today, and that is our species, Homo sapiens. But other hominids have existed in the past. If you're interested in that, we talk about it in historical geology, but I'll just introduce you to um, one of the hominids that our ancestors met with, and they are the Neanderthals. This is what a Neanderthal looks like. And Neanderthals are much different than us. Let's take a look at their skeletons. On the left, you have a human, a hominid that is called Homo sapiens, modern humans. And on the left, you have a Neanderthal. First thing that's different is look at how the ribs flare out and come to this bone here. And the bones are much thicker. Neanderthals were physically strong. They left Africa before Homo sapiens. So about 150,000 years ago, the Neanderthals left Africa and conquered the world. The Middle East, Europe, Asia, South America. Our ancestors didn't leave Africa until 100,000 years ago. So when they went to the Middle East and Europe and Asia and South America, somebody was already there. The Neanderthals were already there. To make a long story short, two things: they're not here and we are. So what that means is we wiped them out. We can see that their villages disappear, and the main reason is because of the difference in weapons. The Neanderthals Neanderthal males, their most prized weapon was this spear that they would carry around. Big, heavy spear. You can't throw that kind of spear. You have to stab with it. Whereas our ancestors developed the throwing spear, which allowed for us to kill them from a distance. That was a huge advantage. Neanderthals were not stupid as they were depicted in the past. They buried flowers with their dead. They cared about the others. They buried them. They made clothing. They made jewelry. Let's take a look at some of their jewelry. I just stopped using the stupid vape. Sorry. Here's some jewelry. Neanderthal jewelry. This is a makeup kit. They would color themselves, maybe for war paint, or maybe just to look good. The Neanderthals, uh, though, are exist within much of the human population. Anybody who's has ancestors who left Africa have some Neanderthal in them. Why? Well, there's clear evidence that when Homo sapiens left Africa 100,000 years ago, they mated with some of the Neanderthals. They were like the Vikings. The Homo sapiens, when they left Africa, they came into contact with the Neanderthals. They would wipe out the Neanderthal um, communities, which were usually from between 10 to 20 people, and they would take the attractive females and mate with them. How do we know that? Because we find skeletons that are half Neanderthal and half human. And if have you done 23andMe or Ancestry.com or anything like that? If you've done any of those things, um, let me close something because there's too many things open. If you've done some of those things, then you know that how much Neanderthal you have in you. I've quite a bit Neanderthal in me, but who has the most Neanderthal in them? Well, redheads do. Why? Well, we find that about 50-60% of Neanderthals were redheads, and red hair did not exist in the human population until we bred with the Neanderthals. So if you're a redhead, you've got a lot of Neanderthal in you. Anyway, we talk more about that in historical geology. Now we're going to move on to the next chapter, which is about earthquakes. So chapter 9, ladies and gentlemen, we're going to start with chapter 9, crustal deformation and earthquakes. I don't know if you've ever experienced an earthquake before, but if you grew up east of the Mississippi River, you've never experienced a real earthquake. I got my PhD at the University of Southern California, and like you, I'm from back east. Well, I'm from Jersey, New Jersey, and so I'd never really experienced an earthquake. Though as a geology student, I learned a lot about earthquakes. The first earthquake I experienced was back in the '90s, and that was the Northridge earthquake. I still remember it because I was lying in bed and I felt the bed shake up and down. And then I looked to my ex-wife over there sleeping there. And then I got up and then I had this big bookshelf with all these heavy geology books, and it came down and it missed me by 1 inch. And I thought to myself, God, I almost got killed by my geology books. And I remember a good friend of mine, Craig Magnuson. He's a native Californian, a surfer dude, and he calls me on the phone and he says, "Dude, are you doing all right?" And I said, "I almost got killed by my geology books." He said, "Dude, you didn't bolt the bookcase to the wall," which means you're an idiot. It was all Californians know you bolt your bookcase to the wall, because if the bookcase comes down, it's going to kill you. And also, I didn't know that people bolt their furniture down to the floor. If you don't, you're going to get killed by your furniture. A lazy boy sofa going at 30 miles an hour is going to kill you. So you got to go to Home Depot and get these kits and bolt everything down to the floor. And I learned these things when I was in California. Here you have some faulted rocks. You learned a little bit about this in relative dating. I can see a whole bunch of faults here. I can see this one here, 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 here. Notice that, for example, this red rock, which is Arcos, it's the same as this red rock here. So there's a fault between the two, and this side moved down and this side moved up. So you can even tell which side moved up or down. Look at this shale layer here. You could use that. This side moved down compared to that. This side moved down compared to that. What causes these faults? These faults are caused by stress. Stress. So we need to know what stress and strain are. Stress and strain. Stress, let's first do it mathematically. You probably learned this in physics. Stress is equal to force divided by area. We measure stress in the United States in PSI, pounds per square inch. The rest of the world measures it in newtons per square meter. But stress is basically just, well, let me show you. So here's a table here. If I push down on this table, I'm putting some stress on this table, right? If I was 350 pounds, 6'5", and a football player, maybe I could put more stress on this table. If I put enough stress on that table's going to break, right? Same with rocks. If you put enough stress on rocks, the rocks are going to break. When the rocks break, you have an earthquake. It's that simple. What then is strain? S-T-R-A-I-N. Strain. Strain is equal to the change in volume of an object divided by the original volume. In other words, strain means, gosh, I wish I had imagine I had a rubber band. I don't have one right now, but imagine I had a rubber band. And if I were to pull that rubber band apart, it would change its shape. The more rocks change their shape, the more the shape of the rock has changed due to stress, the more strain has occurred. Another way of saying it is the more stress you put on rocks, the more they're going to strain. And they're going to change shape. But they can only change shape so much. If I take a rubber band and pull it apart, I'm putting stress on it. And I'm causing it to strain. But what's going to happen if I pull it apart far enough? Then it's just going to break. Right? So if enough strain occurs, you're going to get, the rock will break, and then you get an earthquake. That's the way earthquakes occur. Stress on rocks causes strain, and if enough strain occurs, you get an earthquake. We're going to call it, that'll be it for now. We'll have another video soon.